Hi, Professor Kaplan here, Charles Kaplan. I'm a retired college professor. I taught economics and applied math at the undergraduate and graduate levels for about 20 years here in New York. And let's see. Today, what we're going to do is we're going to find the midpoint of a line, and we're going to find the distance between the 2 points. So let's just get right at it. So let's say we have 2 points on a graph. Say one point's over here and the other point's over here. We have a line in between them. And we want to know the midpoint of that line, somewhere around here. And we want to know the distance between the 2 points. So let's see how we can go about this. The midpoint formula to find the x is equal to x sub 1 plus x sub 2 over 2. And to find the y is y sub 2 plus y sub 1 over 2. So if we had 2 points such as, well, let's start with a new sheet here. Let's start with a clean sheet. All right, how about, well, -3, -7, and 2, 5. So there's 2 points. If we graph them, let's see, 2, 5 would be up here. -3, -7 would be down here. So our graph would look something like this. Our midpoint's going to be around here someplace. So let's find the midpoint first. So for x, it's going to be -3 plus 2 over 2, which is -1 over 2, which is -1/2. And for y, we have -7 plus 5 over 2, -2 over 2, which is -1. So the midpoint is located at -1/2, -1. So right about here. -1/2, -1. So there's the midpoint. Now what we want to do is we want to find the distance. Now, the distance formula is the square root. I'm going to show you how easy this is and how it relates to the Pythagorean Theorem. It's mind-boggling, let's put it that way. So it's x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. Now, let's do this first. Let me show you how this relates to the Pythagorean Theorem. So let's take a graph, and we can use a graph similar to what we had up here. Oops. No good if you can't see it. And this is distance. So, okay. So let's label this point x sub 1 comma y sub 1. Now, if I go ahead and I drop down a vertical line and throw in a horizontal line, okay, well, this point right here is going to have the same y value as this point to the left, but it'll have a different x value. So we can call this x sub 2 comma y sub 1. Now this point here, this is going to have the same x value as x sub 2, but it's going to have a different y value. So this is going to be x sub 2 comma y sub 2. Now that's the trick right there. That's the whole thing. So how do we get this distance, the length of this line segment right there? Well, that is y sub 2 minus y sub 1. And how do we get the length of this line segment between x sub 1 and x sub 2? That's just x sub 2 minus x sub 1. Now, if we were using the Pythagorean theorem, right, and we called this c, right, we would have a squared plus b squared equals c squared, right? We could call this a and this b. So in this case, let's let a squared equal x squared minus x sub 2 minus x sub 1. So we get x sub 2 minus x sub 1 squared plus b squared, which is y sub 2 minus y sub 1 squared, and that's equal to c squared. Now, if we want to find the value for c, we take the square root of everything on the left-hand side, which is this is x sub 2, not x squared. Sorry about that. X sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. We take the square root. Well, guess what, folks? We already saw that the distance formula is the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. So that's where the distance formula comes from. The distance formula is nothing more than the Pythagorean theorem. Easy peasy. So it's, I find that it's always helpful to know where this stuff is derived from. It just didn't drop in out of the air. It didn't fall off a tree. It didn't just show up one day. Somebody said, oh, look, I got a letter in the mail. The distance formula. Isaac Newton wasn't sitting down next to an apple tree. The apple fell down. He said, oh, the distance between where that apple was and where it is now, that's x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. And you take the square root of that. No, it didn't happen like that. This is where it came from. It came from the Pythagorean theorem. So, let's go back to that problem I had where we found the midpoint of -3, -7, and 2, 5. So let's go back to that and find the distance. -3, -7, 2, 5. So remember, we have to keep track. We have to keep close track of what we're labeling. So This is x sub 1, y sub 1, x sub 2, y sub 2. So the distance is equal to the square root of, well, I'll write it out again, x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. So d is equal to the square root of, well, negative 3 minus 2 squared plus negative 7 minus 5 squared, and we're taking the square root. So d is equal to square root, well, negative 3 minus 2 is negative 5 squared, plus negative 7 minus 5 is negative 12 squared. So d is equal to the square root of 25 plus 144, which is equal to the square root of 169. And we know that the square root of 169 is 13. Now, that's one way to do the problem. Here's another way to do the problem. We can plot these points, 2, 5, and negative 3, negative 7. Now, if we want, we can draw a horizontal and we can draw a vertical line. And this point here is 2 and negative 7. So the distance from negative 7 to 5 is 12. And the distance from negative 3 to 2 is 5. So we can use the Pythagorean theorem and we could do 5 squared plus 12 squared equals, and we'll let this equal c squared. So 25 plus 144 equals c squared. See where this is going? C squared is equal to 169. C is equal to the square root of 169. So C, actually, technically it's plus or minus, but we're not going to use the minus because until we get the vectors, we're not going to have negative distance. So C is equal to 13. So we can also do that problem using the Pythagorean theorem if we drop down 2 legs. Okay, so that is how to calculate the midpoint and the distance using our midpoint and distance formulas. So let's go ahead and do some more problems. All right, how about negative 2 comma 5 and 4 comma negative 3? So first we're going to find the midpoint, then we're going to find the distance. Let's see what this looks like on a graph. So we have negative 2, 5, and 4, negative 3. It's going to look something like so. The midpoint will be somewhere around there. So the midpoint x is negative 2 plus 4 over 2, which is 2 over 2 equals 1. And the midpoint of y is negative 3 plus 5 over 2, which is 2 over 2, which is 1. So the midpoint is 1, 1. Task number 1 complete. Now, task number 2, find the distance. Remember, we're also going to be able to drop down a vertical and a horizontal. This is 4, negative 3, and this is negative 2, 5, which would make this negative 2, negative 3. All right, let's get the distance using the distance formula. So d is equal to the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. I'm going to change markers. Okay. So d is equal to the square root of, well, let's see, negative 2 minus 4 squared plus 5 minus negative 3 squared. Take the square root. So d is equal to the square root of negative 6 squared plus, well, this is 5 plus 3, so it's 8 squared. So d is equal to the square root of 36 plus 64. D is equal to the square root of 100. So d is equal to 10. Now we're going to draw this thing. We already did that, didn't we? Okay. Well, I'll do it again. That, 4, negative 3, negative 2, 5. We're going to drop down a vertical and write in a horizontal. This is negative 3, negative 3. So that's going to give us, let's see, the distance here would be from negative 3 to 5 would be 8 units. And the distance here would be from negative 3 to 4, which would be this is negative 2. Negative 2, comma negative 3. And this would be 6 units. So we would have 6 squared plus 8 squared equals c squared. 36 plus 64 equals c squared. C squared equals 100, so c equals 10. Gives you the same thing. If you ever get stumped and you can't remember the distance formula and you can't remember how to derive the distance formula on a test, you can always turn, given 2 points, you can draw a line between them, and you can always drop down a vertical and draw in a horizontal, and you can always use the Pythagorean Theorem to calculate the distance between those 2 points. Taking a quick drink of water. So you can always do that. There's more than one way to skin a cat, as they say. Okay, let's look at another problem. I have a few more of these we're going to do. Okay, how about 3, 2? And 5, negative 2. Let's graph it real quick. 5, negative 2. 3, 2. It's a line like so. All right, let's calculate the midpoint of x. Is 3 plus 5 over 2, which is 8 over 2, which is 4. And the midpoint of y, which is 2 plus negative 2 over 2, which is 0 over 2, which is 0. So the midpoint is 4, 0. So right here, right there, 4, 0, that's the midpoint. And this is 3, 2. Okay, so 4, 0 is the midpoint. Interesting. All right, let's calculate the distance. So the distance is the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. So we've got 3. I'm going to make this x sub 1 and this y sub 1 and this x sub 2 and this y sub 2. It'll make it a little bit easier. So 5 minus 3 squared plus negative 2 minus 2 squared. So d is equal to the square root of 2 squared plus negative 4 squared. So d is equal to the square root of 4 plus 16, which is the square root of 20, which is the square root of 4 times the square root of 5, which is 2 root 5. Sorry about that. 2 root 5. I'll just go through this once more with you. It's 2 squared plus negative 4 squared, and then d is square root of 4 plus 16, which is the square root of 20, which is the square root of 4 times the square root of 5. Square root of 4 is 2. Square root of 5 is just it. So we wind up with 2 root 5. Okay. So that's the distance. We could have also done this. We could have dropped down a vertical, form a little right angle, and this would be 3, negative 2. So from negative 2 to 2, that'd be 4 units. And from 3 to 5, that'd be 8 units. Three to 5 is 2 units, sorry. I knew I was doing something wrong there. That was the pregnant pause. Okay, so that gives us the Pythagorean theorem to use, so to be 2 squared plus 4 squared equals c squared. 4 plus 16 equals c squared. C squared equals 20, so c equals plus or minus square root of 20, so c equals the square root of 20, which is the square root of 4 times the square root of 5, which is equal to 2 root 5, just as we had. Okay. Normally, if I was in a classroom, I would say, any questions? Can't do that here. All right, let's do another. Okay. How about 5 negative 3 and 1 comma 4? So if we graph this thing, we have 5 negative 3 and we have 1 4. Looks something like this. And if we were eventually, we're going to drop down a vertical and a horizontal, forming that. And that point would be 1 comma negative 3. All right, let's use the distance formula. We're going to find the midpoint first. Sorry. So the midpoint of x is 5 plus 1 over 2, which is 6 over 2, which is 3. And the midpoint of y, which is negative 3 plus 4 over 2, which is 1/2. So the midpoint is 3 comma 1/2. Okay, now let's find the distance. So d is equal to the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. So d is equal to, well, the 2 points are 5 comma negative 3 and 1 comma 4. So 5 minus 1, the square root of 5 minus 1 squared plus negative 3 minus 4 squared, which gives us the square root of 4 squared plus negative 7 squared. So d is equal to the square root of 16 plus 49. If my arithmetic is correct, it's equal to the square root of 65. And since, let's say, we can't do very much with 65, we need to leave it that way. So that's the distance, the square root of 65. Now, if we go back up to the graph, the distance from down this leg, the long leg's length, is negative 3 to 4, which is 7 units. And the length of the short leg is from 1 to 5, or 4 units. So that means that using the Pythagorean Theorem, we get 4 squared plus 7 squared equals c squared. C squared equals 16 plus 49. C squared equals 65. So c equals plus or minus the square root of 65. Because we don't have negative lengths at this level of your mathematical learning. You will be able to do negative lengths once you get to calculus and vectors in particular. You can have negative distance there. So this c is equal to the square root of 65. All right. I hope everybody understood that. Let's go on to another problem. We've got, what have we got? -3, -4, and 8, 4. So that's a graph that looks something like this. Let's see. 8, 4 looks something like that. And -3, -4 looks something like this. So that's the graph we're working with. The midpoint will be somewhere around there. So let's go ahead and find it. The midpoint of x is -3 plus 8 over 2, which is 5 over 2, which is 2.5. The midpoint of y is -4 plus 4 over 2, which is 0 over 2, which is 0. So the midpoint is 5/2, 0. All right. Now let's find the distance between these 2 points. We know that d is equal to the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared, taking the square root of all that. So let's see, the points that we're working with are -3, -4, and 8, 4. So we have -3 minus 8 squared plus -4 minus 4 squared. So d is equal to the square root of, well, -3 minus 8 is -11. -11 squared plus -4 minus 4 is -8 squared. So d is equal to the square root of 121, which is 11 squared, plus 64, which is equal to the square root of 185. And I happen to know that 185 is equal to 37 times 5. So there's nothing we can do about 185. The factors there are, that's its prime factorization. So square root of 185 is as good as it gets on this one. So let's go back up to the top, draw in horizontal, drop down a vertical. This point is 8, 4. This point is -3, -4. And this point is 8, -4. All right, the -4 comes over from here, and the 8 gets dropped down from here. So if we go by units, -4 to 4 is 8 units, and -3 to 8 is 11 units. So we come back down here using the Pythagorean Theorem, and we get 8 squared plus 11 squared equals c squared. So 64 plus 121 equals c squared. C squared is equal to 185. So c is equal to plus or minus the square root of 185. Since we don't care about the negative root, c is equal to square root of 185. So again, we can do it both ways. We can do it using the distance formula over here, and we can do it using the Pythagorean theorem from up on the graph. Your teacher is going to want you probably to use the distance formula, but if you get stuck, use the Pythagorean theorem. Graph it, draw down a vertical. So let's take a point. Let's call this will be our last problem. 2, negative 2, 5. And we'll go over to here. We'll call this 5, 1. Okay, let's make this our last problem. So let's see, we have negative 2, 5 and 5, 1. So the midpoint of the x is negative 2 plus 5 over 2, which is 3 over 2, or 1.5. And the midpoint of y is 5 plus 1 over 2 equals 6 over 2 equals 3. So 1.5, 3, we'll call that 3 halves, 3. So there's our midpoint, which is 3 halves, 3. Now let's work on the distance portion of this thing. Okay, so we have the points are negative 2, 5 and 5, 1. So d is equal to the square root. I'm getting a little hoarse. I need a little drink of water here. Okay. So the distance is going to be, let's see, negative 2 minus 5 squared plus 5 minus 1 squared. So d is equal to the square root of, let's see, negative 5 minus 5 is negative 7 squared, plus 5 minus 1 is 4 squared. So that's going to give us the square root of 49 plus 16. Oh my. So d is equal to the square root of 65. And that's it. We can't do anything more with the square root of 65. Now, one thing we can do here, we can drop down a vertical, we can draw in a horizontal, and that point would be negative 2, 1. So this length is from 1 to 5, which is 4 units. And this length is from -2 to 5, which is 7 units. So if we use the Pythagorean Theorem, we get 4 squared plus 7 squared equals c squared. 16 plus 49 equals c squared. C squared equals 65. So c is equal to the square root of 65, which is exactly what we got right over here using the distance formula. So there you go. You have it two ways, using the distance formula and using the Pythagorean theorem. And as I showed you from the very beginning of this video, the distance formula is derived from the Pythagorean theorem. If you didn't see the beginning of the video, go back to the beginning of the video and you'll see that derivation right before your very eyes. So this is Charles Kaplan, retired college professor, taught economics and applied math at the undergraduate and graduate levels for about 20 years. If you liked the video, found it helpful, please click subscribe. That will help me. And I hope everything is healthy, happy, profitable for you in life. And I hope you have a great day today, and I hope you found this video to be helpful. That's it. Signing off. Good night or goodbye.